Hello everyone, welcome to another episode of Black Guy Does Physics, where we simplify physics problems. If you have a math related problem or a physics related problem that you'd like me to solve, please leave a comment below. Apart from that, like, subscribe, smash that button. Smash the button. Smash the button. You know you want to just smash it. Smash the button. Alright, let's get it cracking. Today we're looking at a classic, let's see here, motion problem, I think it is. One runner is trying to catch another runner. Now, as I look at this thing, I see a bunch of words, man. A bunch of words. Once I see a bunch of words, that's an automatic indicator that there's a high probability I'm going to be drawing something. So I read, Mary and Sally are in a foot race. When Mary is 22 meters from the finish line, she has a speed of 4 meters and is 5 meters behind Sally, who has a speed of 5 meters per second. Sally thinks she has an easy win, and so during the remaining portion of the race, decelerates at a constant rate of 0.4 meters per second to finish line. What constant acceleration does Mary need during the remaining portion of the race if she wishes to cross the finish line with Sally? Dope. So this, once you've read, the first thing you should do for any problem that you're solving is to try to figure out what type of problem it is. This problem is a motion problem. Now the question is, hey black guy, how do I know that this is a motion problem? Well, this motion problem is because you see that you're given some speed, you're given some distance, and you're given some acceleration. So whenever you have 5 out of those measurements, this initial speed, the final speed, the acceleration, the distance, and the time, if you have 3 out of those things, it is a motion problem. So since you have 3 out of those things, it's a motion problem. You also want to indicate, for all your problems, you want to indicate which direction is positive, which direction is negative. I am going to take this way to be positive, that way to be negative. Dope. Cool. Now I get to reading again. Do you have to read 2 times? No. When you get good at this, you just read it one shot. But if you're just starting out, read it twice. I see all this writing. As I said before, I have to draw. Okay? So, I know that it's 2 people, Mary and Sally. I'm not going to use the diagram that they give me here to set myself up for failure. Nah, bruh, not happening. I'm going to draw 2 separate things. I know that they're going to the finish race, and somewhere I remember that they're going to be catching up with each other at the finish. Somewhere I remember this. So this is your finish line. Right? This is your finish. I remember something reading. So one person will catch one person at the finish line. Don't worry about my artistry. It's very well. I went to school for it. All right. So let's go. When Mary is 22 meters from the finish line. Boom. So 22 meters. I'm going to draw that. So Mary is 22 meters from the finish line. This is Mary. And she's going to the finish line. So this distance I'm going to call x1 because I'm going to call Mary 1. So this is Mary and I'm going to call her 1 because it's 2 things. So I'm going to call her 1. All right. I also want to check what type of motion it is. If it's a constant acceleration motion or a constant velocity motion. When I look at this and I saw that both of these ladies had constant acceleration. So both of them have constant acceleration. Now, if the motion is constant acceleration and I'm drawing, I want to label their initial velocities, their accelerations, and their distances and their time. So automatically, I could label all those things, right? I could say that there's some acceleration. She must have some acceleration. She must have some time. She must have some V1, and she must have some V01. I could label all of that, and she must have some X1. That's my X1. Okay? So now, as I read, I could go, okay, Mary is 22 meters from the finish line. So that's my X1. So my X1 is equal to 22 meters. She has a speed of 4 meters per second. So now I ask myself, is that my V01 or my V1? Well, she has a speed at that point in time. So that should be your V01. So that's my V01. That's 4.0 meters per second. Now, she's 5 meters behind Sally. So now we're introducing Sally. Oh, wow. Sally, you're getting introduced. So she's 5 meters behind Sally. So I'm going to draw Sally down here. Here you go, Sally. Sally, should I move you over somewhat? Yes, Sally. Oh, no! Let me just erase this junk. Cool. And draw Sally somewhere here. My artwork. So this now is 5 meters. So I could just draw that as 5 meters. Just write it in 5 meters. So this is now Sally. We already know for Sally that her acceleration, she has an acceleration too. So I could automatically write in an x2. She must have some x2. She must have some a2. She must have some t2. She must have some v02. And she must have some v2. Automatically. I just put it down. Okay? As I'm reading, I'm going to write down what these things are. So, one of the things that you must realize in these problems whenever you have two objects moving or one object with multiple parts of the motion is that you have to know when you start caring about each thing's motion. So, for Mary, when did we start caring? We start caring when Mary was 22 meters from the finish line. When did we stop caring? When she's at the finish line. So that's my initial. Over here is my initial, and this is my final. So I'm good with that. So let's look at Sally. It says, behind Sally, who has a speed of 5 meters per second. So now I start caring about Sally right here. Okay, so that's my V02. She has a speed of 5 meters per second. 5.0 meters per second. Sally thinks she could easily win, and during the remaining portion of her race decelerates at a constant rate. So she's decelerating 0.40 meters per second, which means that her acceleration is negative 0.40 meters per second squared. And why is it negative? Because I chose to the right to be positive. So because I chose to the right to be positive, then if she's slowing down, then to the left, the acceleration would have to be in the opposite direction of motion, so it would be negative. So that's our A2. So now it's asking for what is the constant acceleration that Mary needs during the portion of a race. So we're looking for A1. That is what we're looking for. So now, before we move on, at this point in time, kids will start to just start hunting. Nah, bro. You don't hunt. You let the thing do the work for you, right? You're going to hunt later, but you have to let the thing do your work for you. You have to look if there's any relationships. You have to understand the situation before you start hunting for equations. So let's go through this real quick. You have to know what V01 represents. You have to know what T1 represents. You have to know what A1 represents. You have to know what X1 represents. You have to know what V1 represents, right? So V01 represents the speed that Mary's going at when she's 5 meters behind Sally. Cool. T1 represents the speed that Mary's going at when, not the speed, the time that Mary took from when she was 5 meters behind Sally to when she caught Sally. A1 represents the acceleration during that period. X1 represents the distance Mary traveled from when she was 5 meters behind Sally to when she caught Sally. V1 represents the speed that Mary's going at when she caught Sally. Dope. So you have to remember what that means. If you can't remember, just write it down. What does V02 represent? Now, V02 represents the speed that Sally's going at when Mary is 5 meters behind her. T2 represents the time it took from when Mary was 5 meters behind Sally to when Mary caught Sally. That's an important one right there. A2 represents the acceleration during that period. X2 represents the distance from when Sally was 5 meters ahead of Mary to when Mary caught her. In other words, the distance Sally traveled when Mary was 5 meters behind her to when Mary caught her. That's X2. And V2 represents the speed that Sally was going at when Mary caught her. Good. Why do we need to know what these things represent? Because if we know what these things represent, then we could make the most important thing in solving these problems. We could make relationships. So, How do we make relationships? We look at, usually you look at the velocities, the displacements, and the times. The x, the v's, and the t's. I usually start with x's. Why do I start with x's? Because it's usually, you could see it from the figure. So this one, most of you would have gotten in your head. You could have literally just say, yo, I don't need to do anything too crazy here. I could see that x1 must be equals to x2 plus 5 meters. And if that's the case, I could figure out what x2 is real nice and easy because I know what x1 is, right? So I think x2 should just be equals to 17 meters. So hopefully my math is right. So that's done. Oh, sweet. Cool. Done. You could have seen that, but most kids pick up on that from quick. But I don't like to jump ahead. I like to do things systematic. The reason why I want to do it systematically is because sometimes this is not as clear as it is here. So I want to keep repeating the same thing over and over and over. I don't want to make any assumptions, man. So now let's check the velocities. Does this speed, V01, has anything to do with this speed? Nope. They're going at two different speeds. What is V1 and V2? Does Mary's speed at the finish has anything to do with Sally's speed at the finish? No. So there's no relationship there. Now let's look at the times. Does T1 and T2 have any relationship? Let's check what T1 means again. T1 means the time from when Mary was 5 meters behind Sally to when Mary caught Sally. T2 represents the time from when Mary was 5 meters behind Sally to when Mary caught Sally. So from that, if you read that and understood that, then you'll see that the T1 is equals to the T2. That's it. That is the hardest part. Now, if you could make those relationships, then all you have to do now is sit back and let these equations do the work for you. This is the part I like. No thinking involved right now. Let's go, W's. Now, you're going to say, if I want to solve for A, I need an equation to solve for A. Yes, you do. So there are two sets of equations. You could use a constant velocity or a constant acceleration. Obviously, this isn't a constant velocity. So I don't even think about that equation, which is v is equal to x over t. So I need the constant acceleration equations. So how I go about solving for A or looking for A? I go, I need equations that have A in it. That makes sense? That would be good. So this one, gone away. Doesn't have an A, bro. Ta-da! We're looking for, I'm sorry. I should put 4A1. Okay. So now, can I move this down a bit? Yep. Why did I mess my thing up? Hey, this is all live, baby. It's live. So I'm trying to write this for A1. So, I don't like how that looks. Sorry, I'm a stickler for this stuff. So we're looking for, wasting time here, sir, for A1. Okay, cool. So I'm looking for A. Do I have T1? No. Do I have V01? Yes. Do I have V1? No. So there I'm missing V and T. All right. Do I have X1? Yes. Do I have, this is 0 because you started off at 0. Do I have V01? Yes. Do I have T1? No. No. So I'm missing T. Here. Do I have V1? No. Do I have V01? Yes. Do I have A? That's what I'm looking for. Here. Do I have X1? Yes. So here I'm missing V. So now the question is, obviously, most kids' brains would tell them, nah, bruh, I'm not going to use you because I'm missing two things here. This is a trick. This not a trick. The hack This is how you hack the system. How do I know which one of these to use? The one that is missing t, the one that is missing v. Very simple. Just look up here at the equations that you made up and use the one that has the thing that is there. So in this particular case, I am going to use this one. Why am I going to use this one? Because this one is missing t, and I could use the t from t2 to solve for t1, and I could do that. If I try and use v, it's an exercise in futility, man. You're going to be like a dog chasing its tail, yo. You're just going to be running around. So the hack to it is that you're going to pick the one that is here. This is the system. I'm giving you the system. This is how you beat all these physics problems that they try and trick you with. Okay? So now we're going to use this one. We're going to say x1 is equal to v01 t1 plus half at squared. t1 squared. Now, this means I need t1 to solve, as we have said before. We cannot use any one of these equations. We cannot use any one of these equations to solve for t1. No, we can't. Because once again, you'd be running around like a dog without a tail. No, that's not how you're going to. A dog chasing its tail. So we know that t1 is equals to t2. So go find t2. So what do? Panic? No, I don't panic. All I do is that I go like this. Oh, I need t2. What do I need to solve things? Equations. What type of motion it is? Oh, it's a constant acceleration motion. Therefore, I'm going to use a constant acceleration formulas. Boom. There we go. Boom. Done. So we go again. We check again. Do I know V2? No. Do I know V0? Yes. Whoa. What just happened? Okay. Do I know V02? Yes. Do I know A2? Yes. And I'm looking for T2. So I need V2 here. Okay, cool. We're looking for T. This one we can't use. This one we can't use because they don't have T in it. So do I have X2? Yes. This is 0. Do I have V02? Yes. Do I have A2? Yes. And I'm looking for T2. Okay, dope. Now, that means I could solve for T2. Yay! Clutch. Therefore, X2 is equal to V02 T2 plus half AT2 squared. Good. Now, ladies and gentlemen, this, my friends, is a quadratic equation, which sucks. So, you have to understand that this is a quadratic equation, so you have to solve for T2 as a quadratic equation. So how do you do a quadratic equation? First of all, you want to plug in the numbers. So let me write quadratic. So plug in the numbers. I'm going to plug in. X2 is 17. I'm not going to carry 3 units because if you keep your units in SI units form at the end, everything works out properly. Okay? V02. What was V02? 5. So this is 5 T2 plus half of A, which is, it was what? Negative 0.4. 0.4 times T2 squared. So what I want to do first is that I want to set this thing equal to 0. So I'm going to move the 17 from here to over here. So I'm just going to write 0 is equals to 5T2 minus 0.2 T2 squared minus 17. Now for quadratic equations, if you don't remember, it would be minus b plus or minus the square root of b squared. Square root of b squared minus 4ac all over 2a. So this stuff, what you should know is what is your a, what is your b, what is your c. Your a is the stuff that is attached to your t, to your squared term. So that's a. Your b is the stuff that is attached to your single term. That's your b. And your C is the stuff that is attached to your nothing, which is just your constant. So that's your C. So now, if you remember the quadratic, it is so T2 would be equals to minus B plus or minus the square root of B squared minus 4AC all over 2A. So I'll just set this out. I'm not solving this for you, actually. I'm just putting in the number. So that would be minus 5 plus or minus the square root of 5 squared minus 4 times, what's that? Negative 0.2 times C, which is negative 17, and all over 2 times negative 0.2. I don't know if, hopefully I did that right. Hopefully I didn't make any mistakes with my math, but you could always check it out. Once you find the time, you're going to get some plus or minus something. I think you're going to use a positive time if you get up negative time. And then all you do now is substitute the value, this value of whatever you get here, you're going to substitute it back here because T1 is T2. So whatever value you get, you substitute it back in to this one. So you're going to substitute. Remember, you have to do that part on your own. Substitute T1 into the equation for x1. So I'm going to call this thing equation 1. So you're going to have x1 is equals to v01 t1 plus half a1 t1 squared. And then you could rearrange for a1. So a1 is going to be equal to x1 minus v01 t1 all over, so that's going to be 2 over t1 squared. So that's the compacted version. Now, obviously for me, like switching that at the end like that, you could do it in steps. I'm just doing it all in one shot to make sure that, to save some time. So that's how you hack these problems. Once again, kids, the hard part is here. That's the hard part. The rest of it, you just use the hack, man. You always use the same hack. Just hack it. Okay? Hopefully you enjoyed that. Hopefully it wasn't too long, but as you see, I have to explain everything to you. Okay? Remember, smash that button. Smash it. And as always, kids, don't be a moo-moo.